keeping us right on time, we're going to go into our fourth session, fourth segment, which is focused around infrastructure. And so we have two industry finalists within this category. First, we have PRENAV. They develop AI tools for 3D virtual inspection of bridges, dams, roads, and other civil assets. And second, we have T2D2, AI computer vision damage detection for infrastructure inspection. And so to start us off, PRENAV, handing it over to you.
Well, hello, everyone. I'm Nathan Shute. I'm the founder and CEO of PRENAV, and our focus is on digitizing and inspecting critical infrastructure. And if you look at the way that most large civil assets are inspected today, it's involving climbers on ropes or scaffolding or bucket trucks. And it's a process that's slow, expensive, dangerous, and fairly error-prone. You can look at the cost of these manual inspections at height, ranging from $5,000 to $100,000 or more per structure. And the data that's captured is often stored in low-resolution PDFs as thumbnails, or it's hand measurements, defects noticed with the naked eye, and then often collated in a spreadsheet or an Access database. So this makes it very hard to really pull meaningful insights out of this data and to do anything other than a manual process. So what we're building at PRENAV is a new type of software that we're calling visual inspection automation software. So using a drone, we can fly around a bridge or a dam, take thousands of photos from all different vantage points, and create a 3D digital twin with high resolution photos all spatially overlaid on the model, and the ability for AI to detect things like cracking and corrosion. So I'll jump right into a quick demo. This is a very famous bridge in California on Highway 1 that we flew with a drone. Took about 4,000 photos and created this digital model of the bridge the very next day. So it took about a couple hours to fly it. Every photo is taken just a few meters away from the bridge, and they're all able to be browsed spatially in 3D using this point cloud of the bridge as the outline, or as the framework for how to navigate around it. So again, taking this experience of inspecting on ropes or on a boom truck and making it virtual behind a computer screen. If you notice something like cracking, an inspector can go in and tag that. They can measure it and add it to a report. And this includes all of the standard reporting settings for the Federal Highway Administration around structured groupings, elements, defect types, and so on. And then we have AI that's overlaid, where you can detect things like cracking, spalling, some damage in these side railings of the bridge, exposed rebar, and so on. So that's our core product. And just in the interest of time, I'll move through this quickly. Our AI is really modeled around two main types of surfaces. One is concrete, so we have a lot of AI for concrete, and the other is around steel, so cracks in steel and rust, missing fasteners, faulty welds, and paint. Our customers are some of the largest owners and builders of infrastructure around the world, include BNSF Railway, Class 1 railroad. They own thousands of railroad bridges. Lockheed Martin, we're helping them with aircraft inspection on their assembly line. IHI Corporation, a large international bridge builder. And we also do telecommunications towers, dams, and a number of other things. But just to kind of give you a sense of who we're serving. These are a few screenshots of different types of structures that have been digitized with our platform, from large arch bridges to railroad trusses to dams and telecommunications towers. Now, to clarify, PRENAV can fly the drone, or our customers can fly the drone. We can train you or train your organization, or a third party can do that. You should really think about us primarily as the software and analytics layer. So here's a project where a drone was flown inside and around a dam, reconstructed within our platform. All of the defects and cracks get mapped onto the surface, and then we provide a PDF deliverable with everything painted and measured for archives. And then one final additional service that we provide that I think could be useful across a variety of use cases is synthetic imagery. So one of the ways that we train our AI models to detect defects is by generating our own training data using Hollywood visual effects pipelines. So we can set up parameterized 3D models for, in this case, sealant blobs or for railroad car wheels. And then we can apply defects like cracks or pinholes or paint that's too thin or contaminated, and apply that anywhere on a 3D model of a part or a vehicle. And in this way, we're able to generate, starting with like a SolidWorks file of a part, we're able to generate thousands of perfectly labeled training data, which can actually help to improve the accuracy of AI models. And we're seeing that with our railroad customer, where we actually doubled the performance of their AI model to detect critical defects that could potentially cause a derailment. Just a couple close-up images. So this, I think, could be applied across a lot of different use cases, not just railroad detections or aircraft detections, but really anything that you came to us and said, we have particular training data where we just don't have enough examples of cracks or enough examples of potential critical failures, we could go ahead and render that for you. And we have a monthly service that we provide. So PRENAV is pretty easy to work with. If you needed drone flight operations, we can do that. Digital model creation, digital inspections, painting cracks on actual like physical infrastructure and tracking that over time, or generating synthetic training data. So please reach out if you have something that could be a fit. My email here is below. It's mate@prenav.com, and it'd be great to hear from you. Thanks.
Thanks, Nate. Awesome lightning talk. So then second in the section, and to close out, we have T2D2, AI computer vision damage detection for infrastructure inspection.
Thanks, Sabrina. Hi, everybody. I'm Jonathan Ehrlich from T2D2. Let me go ahead and share my presentation today. Let's slide. There we go. So we all know that legacy inspection methods are antiquated. Buildings, bridges, and infrastructure are still often inspected by rope access, heavy industrial equipment, or traditional scaffolding. These methods are dangerous, they're outdated, expensive, the list goes on as you've heard. One thing that we like to focus on is that the existing building and infrastructure stock is experiencing rapid deterioration at a rate never seen before due to the effects of climate change. In addition, building inspection oftentimes is not very substantial due to the effect of sampling. Hi. I'm Jonathan Ehrlich. I'm the COO of T2D2, the future of inspection. Trained by leading industry civil engineers, T2D2 is a cloud-based SaaS platform that combines our network of drone inspection professionals, artificial intelligence, and cloud computing to capture, detect, analyze, and monitor ongoing structural and building facade damage. This combination of AI and UI allows asset owners to take control of their condition data in a way that they have never had access to before. Through a feature-filled cloud-based data visualization platform, owners can navigate their entire building imagery archive and damage detection digital twin to detect and monitor ongoing deterioration as additional imagery is uploaded. T2D2 can classify over 80 different types of damage across 8 different building materials, allowing users to analyze, estimate, and monitor conditions on an ongoing basis. Here you see our cloud inspection web portal, the dashboard where you can find top red flag alerts. Hold on 1 minute as this loads. Give it a moment. There we go. Top red flag alerts, reminders, and condition overviews. These are some indicative photos of past projects, including brick and stone masonry, concrete with exposed rebar, slate roof, and stucco construction types. T2D2 can accept imagery taken by drones, mobile devices, or cameras. T2D2 can analyze still imagery, video, or thermal images. You're about to see a geotagged elevation drawing where you can click on individual photos and keep clicking all the way down into the individual damage detection. You can also see your stitched orthomosaics, allowing full visibility into your entire building elevation in one view. 3D models are also able to be viewed, giving you a one-stop shop for all visualization and damage detection across view types, not only for single buildings, but your entire portfolio. It's really this combination of our world-class AI damage detector combined with our online inspection cloud that delivers 2 inextricable components of condition inspection. We've been recognized by regulators in the building space as a leader for building exterior facade inspection around the world. We've been fully commercialized for over a year, and we've been used on major iconic assets worldwide, including with some government partners at the federal and local and state levels. We're a proud and growing team of experts in AI, engineering, and software that are uniquely positioned to solve this challenge. Thank you very much.
Thank you. And so now we're going to go into a few minutes of question and answer portion. And I just like to encourage folks, if you have any questions that come up, maybe you haven't chatted in yet, please feel free to do so and we'll make sure to get to them. But so to kick off, just a general question for each of you at T2D2 and PRENAV. And the question is, what computer vision engine tools are you currently using? I'll direct that first to PRENAV.
Sure. So our software is web-based. It's a SaaS model. So customers can log in and view their assets using a proprietary system that we've built ourselves. The AI itself is trained mostly using PyTorch and open source frameworks. That's what we use internally.
So I'll answer that by saying something sort of similar. Our AI is also trained using, as in most proprietary AI is built based on open source frameworks like PyTorch, TensorFlow, et cetera. Ours not only are individual models, but a pipeline of models. So every time that you're choosing to process your inspection imagery through our artificial intelligence, based on your building material type, it's going to flow through a variety of model sequences that goes ahead and process it through a number of different workflows. That's something that we've developed in-house, again, based on those open source frameworks. The other thing also is, of course, your training data. So in our case, our training data is based on our close partnership with a very large civil engineering firm using an image library of over 300,000 images that were used to train those models. And the models, of course, continue to be trained through our relearning process as new projects are uploaded.
Thank you. So then a second question for each of you, and Ron, I'll invite you to come and ask this question.
Sure. Question I had is that your products appear to be in the same market. How would you differentiate your products from each other? And are there use cases where one would be a better fit?
I'm happy to go the other way around if you want. So I'm happy to say that we're definitely focusing primarily in the building space. So traditional real estate buildings for government agencies on the call who do a lot of in-house building inspection. We do some work in the infrastructure space as well, not as much as PRENAV, and we don't have the synthetic image features and products that they offer. So we really do focus on buildings and building facade.
Excellent. Lots of good use cases in the federal space.
Yeah, nothing to add there.
Thank you both. So then a question from Bill Wallace. You found a crack in the concrete. How do you track the handoff and closeout for repair work? Do you track overall system health?
Sure, I think that's a great question. So there's a future direction for our products. We're not focused on that yet in terms of tracking maintenance items and whether things have been repaired. So that's where today it's a clear handoff to our customer who is ensuring that those repairs are taking place. Where we are today, the focus is on identifying defects first. The second sort of area then is tracking changes over time. So if you go inspect the same asset again in 6 months or in 1 year, where has damage grown? Where has it gotten worse? And you can learn a lot about a structure just from getting to that point. And then a future direction would be actually tying together the whole system.
On our side, we do have full project management tools built out in our system. So we are designed to carry that through within T2D2. That includes condition assigning, so you can assign it to individuals who are operating within the platform. You can assign deadlines to them, as well as manually rate conditions or group conditions. So if you have a group of conditions that you want to be included, for example, in your repair work order, you can specify or tag them as to be included in your work order. When you go ahead and create a work order using customized templates or our standard templates for repairs, bids, etc., you can go ahead and do that in T2D2 and then track those conditions on an ongoing basis, whether they're assigned to somebody, whether they're grouped into a work order, and then you can track them across portfolio properties as well. We're also building out integrations into third-party systems like IBM Maximo and other enterprise asset management softwares that some of the larger agencies are using if they want to do project management in those third parties instead.